Hello. Hello, Vicky. Hello, Aminata. Hel Hello, Kian. Hello. Now the chat. Good afternoon, Vicky, for the double. Good afternoon. Good afternoon. That's actually an interesting. All right, anyway, good afternoon, Roger. Good afternoon, Rada. Hi, Bridget. Hello, Aminata for the double. Oh, give me 1 second while other people are coming in and let me this thing. Hold on one sec. Good afternoon, Sonam. Okay. I'll be right. Someone's here. Sorry. Coming. Oh, wait, bear with me for a sec. Uh, Bear with me for a second and we will get rolling. That doesn't make any sense. Uh, hold on. Oh, sorry. Not what I meant to do. Hello. Wait,
Yes,
hold on.
good to
Sorry,
see you.
I'm playing another video. Sorry, by accident.
Hello,
Not what
Brandon.
Oh, yo,
Good to
yo, yo,
see
yo, yo,
you.
yo, yo,
Good
yo.
morning, Professor. Good morning. Good morning. Good morning,
What's
Colin. Good
happening?
to
What's
see
happening?
you.
Sorry,
Good
sorry.
morning. Good morning. Good morning, Xavier. Good to see you. Good,
I don't know why that's happening. Hold
good
on.
morning, Charlotte. Good morning. All right. Good morning, Charlene, Alexis. Good morning,
Okay, that is
Anissa,
really awkward. Hold
Ariana. Good
on. I
morning,
don't know
Ken.
why.
Good morning, Gaia. Good morning, Chanel. Good morning, Charlene with
Where
the
is
double. Good
that?
morning, Anissa with
Hold
the
on.
double.
I'm gonna turn off the sound for
Yeah.
a second because I
Good
don't know.
morning, not with the double. Recent material. So the one that I think you might find the most challenging. So I'm going to do that in a minute. Hopefully that's helpful to your ability to do the midterm. I may, and I'll quickly I'll walk you to it. And anyway, I'm going to make some I'm going to open up the share the practice midterm in a moment.
I don't
And
know.
do like a quick
Sorry.
walkthrough of comments until I get to the problem I want to go over, and then I'm going to go over that problem.
Good afternoon, Professor.
And it's my bad because I thought I already did that. Yes, yes. Yes, someone's reminding me that homework 8 is due the exact same day as the midterm. That is not on purpose. I will change that right now. No, I just, from here on in, I just want.
Okay. Okay, wait. Can you okay, can you hear me? Yes, yes. Okay, okay. So I think I saw the problem, but now I apologize. Bear with me for one more minute. We're going to talk about the midterm in a second, or for the rest of the period, but um bear with me for one more second because now, okay, yeah, sorry. Um
Yo, that's me.
Yo,
okay, sorry. That was crazy. Okay, we're back. I sort of so here is the story. Well, we have a midterm coming up. I would to repeat what, yeah, to repeat what is hopefully sort of clear at this point. Your way of preparing for this midterm is to practice the practice midterm that is already posted in Google Classroom. Your midterm will be very, very similar to it. It is true that if you, and you should use the practice midterm as a means of doing rough drafts leading you up to the final copy that you'll start to make when the actual exam is posted. You should view your exam as something that is a final copy of a very thoroughly presented, detailed walkthrough for me of the inner contents of your mind, your understanding of the process for solving all of the problems in the midterm. I mean, and I was getting questions about this in the other class, so let me just emphasize again, absolutely the 5-step method is the skeleton for what you're doing here. Absolutely, you should do the 5-step method as a minimum and label each step as you go. Even questions that seem very short or straightforward, They're probably not tricks. They may be as short and straightforward as you think. They may be short, straightforward questions that get you answers that you need for subsequent questions. But nonetheless, you need to break everything down into the 5-step method, into diagrams and all of that at least every first time that you introduce a concept. Whenever you're going to explain a concept, especially if it's the first time in your document, over explain the concept. By the time once it's explained in that document, then you can say things like see above, see above. You could, but you, especially at the beginning, you're building a language. You're going to assume that I have nothing next to me other than your document. Like, I don't have your other homeworks. I don't know what other things you understand. And I don't have the original questions to the exam. You're walking me through physics from A to Z with as much over explanation and pictures and different colors and annotations and neatness and thoroughness and clarity as possible. Like, again, the good news is by the time the actual exam is posted, it shouldn't be surprising to you. It won't throw you. I mean, hopefully, you'll have to be careful and look where numbers are changed or details are changed so that you're not literally just copying something, but you will have practiced it all and done rough drafts of it and everything by that time through this practice exam, this old exam that's posted in Google Classroom. And like I said last time, what I don't give just like some clear, straightforward answer key to this practice exam, because that would sort of defeat the purpose. If you had because your actual exam will be similar enough to this practice that if I just literally gave you a self-contained answer key, that would defeat the purpose. On the other hand, in a couple of minutes, once I shut up with this, overview, in a couple of minutes, I'm going to walk you through one of the problems. Or I'm going to do a little walkthrough of the practice exam, like right here now in real time. And you'll see that there's other videos, in the past where I do a similar thing. I'll walk through one of the problems right now. And I'll probably walk through a different problem on Wednesday. Or I might even walk through different problems in different sections this week, maybe. So if you watch all the videos from all the sections, maybe you'll even see me walk through like most of the exam. Totally fine. But you still have to make you have to make sense of the sense I'm trying to make and put it together in your way when the exam is posted. Quick note on that. Because you actually have until Wednesday to turn this thing in rather than the typical Monday, because we don't have school Monday, you have till Wednesday to turn this in. For that reason, and also because the lab professors were very cool, like super helpful and supportive and vigilant about reaching out to me, and your lab professors in all sections want to make sure to give you time during a lab period this week to work on the practice exam and get guidance from the lab professor and so forth. So you will. So your lab period this week, you haven't had it yet, I don't think. You could tell me in the chat who's your lab professor and when you have lab, if you could tell me in the chat. But in fact, yes, if you could tell me in the chat who your Walter's out there. Okay, so I've already great, thank you very much. So I reached out to Walt. So Walter's, that's what she's going to do on Thursday, is spend the lab period on the practice exam. Now, how she's exactly going to do it is totally up to her. Like, she does it differently different semesters. Maybe she'll give you a bunch of time to work on it your own and help each other, and she'll answer questions, or maybe she'll talk about it at the board, that's up to her. But again, you won't get literally an answer key, but you'll get a lot of guidance on the practice exam. And I can certainly tell you that that the way to study for all of this is to just rip to shreds the practice exam. If you're super confident that you understand by the end of the week every part of the practice exam, you will be good on the real exam. Be careful, obviously. It won't be identical, but yeah, if you make a priority out of doing different drafts and collecting all your understanding of the practice, you'll be good on the real exam. Like, I can tell you that. So for that reason, because your lab instructor wanted to give you time, and you don't have lab until Thursday, and that's true of some other classes as well. And one class doesn't have class till Friday. One lab. So for that reason, I'm not posting the exact the actual exam till Friday night. I originally said Thursday. Usually it is there. Often it is Thursdays, but this semester I'm going to post it Friday night. I apologize for the change, and I changed it in the Google Classroom like during the weekend, but you may not have noticed. That is a change, but it's a change so that you have a full extra period to review and practice the midterm this week. And you still have 2 extra days to turn it. Like it would normally be Thursday to Monday, so now instead it's going to be Friday to Wednesday. Okay, I just hope you note that change. Wait, just raise your hand if you heard what I just said, or if you understand what I just said. Like I'm okay. Thank you, Keon. Thank you, Caitlin. Thank you, Bridget. Thank you, Sunham. Okay. Thank you, Victoria. Okay, so right. So the exam, and it says in Google Classroom, if you check the exam, your actual exam will be posted Friday night, not Thursday night. Right. But you'll have till Wednesday till 12:15 on Wednesday to turn it in. And again, you can help each other, you can go on the web, all that stuff. But you gotta understand that I understand that you can do whatever you want to do this exam. Therefore, you have to view it as a thorough presentation, not just as a bunch of answers. As I said to the other class, I mean, I think maybe this is clear to you guys because you're not, but like it's so the priority of the way I grade is the 5-step method. Like that's the thing about the 5-step method, why you've been practicing on homework is you want to use that as your guide and your self-grading rubric. Like what I look for is the steps. So the more you can do the steps and explicitly label, here's my step 2, here's my step 3, the more you can walk me as a skeleton, the more you can walk me through all your work that way, or whenever you think a step doesn't apply, like that might be true. Okay, like I think a question might be so quick or small, you might think, wait, this is just too, but then just say it. Like instead of doing the 5-step methods here, or I feel that here is step 1 and 3. I don't feel that step 2 apply or whatever, but just acknowledge always as you go, just use the 5-step method as your explicit guide because you'll be communicating straight to the grading rubric if you do that. Like honestly, and therefore it is possible. It's possible to get a bunch of final answers on this thing. It's possible to get like almost all of the final answers wrong and still get an A on the exam if you've really walked through the whole process authentically. But conversely, it's possible to just have a bunch of correct answers. But if there's no process, no steps, no explanation, then it's possible to not do well. So it's about the process. And of course, my belief, my experience suggests that the more you focus on the process, the more likely it is your answers are going to be right anyway. So, but okay. So Keon and Fabia, are your hands still up just from when I asked before, or do you have a question? Oh, repeat. Oh, can I repeat that? Yes, but repeat. Sorry, what am I repeating? Well, if you knew, then I wouldn't have to repeat it, right? Am I repeating that the exam is posted Friday? Not. Oh, you got it. Okay. And Fabia, you're cool. I mean, thank you for raising your hand from before. But if you still have a question, feel free to ask it, or I'm gonna put your. Okay. Well. Okay. So. Uh, so again, there is no, I mean, I know someone asked this last time and it was legitimate, or maybe it was in the other. Someone asked last time, like, is there like literally an answer key to the practice exam? No, there isn't, but there's a lot of answers and guidance out there that you're welcome to take advantage of, some of which I'm about to give you right now. But you've got to be sort of paying attention to grab at it. Okay, so the next 2 days is me trying to help you with the exam. So I, what's on the board right now it's not all that you need to know for the exam, but it's kind of a summary. Like because the exam is really about simple harmonic oscillation and wave propagation, right? And the top equation is the ultimate summary of all of the intricacies of the top equation is the simple harmonic oscillation equation, and the bottom equation is the wave equation. They're both second order differential equations. The top one is a second order ordinary differential equation, and the bottom one is a second order partial differential equation. If you can follow the nuances implied by each one, if you see how waves are built from oscillations and you see how they're similar but different, like then that's what this exam is about. I'm not saying if you memorize those two equations, you're set on the exam, but I'm saying that's what the exam is about. Oh, and therefore, wait, yeah, therefore the exam does cover, I mean, all the homeworks that we've done so far, through homework 4 and all the lab, like you're on lab, you just, you're not up to lab 4 yet. Anyway, any lab that you've done so far is fair game for this exam. Okay, so I'm going to switch. You could stop me at any time with any questions, logistical or otherwise, about the exam, but I'm going to switch screens and sort of walk you through the practice exam for a minute. So make sure we're on the same page. Okay, so bear with me. I'm going to switch screens.
Mm.
Okay. So, okay, right. So this is your practice exam, but your exam will look very much like this. Note, so you're given equations, right? So don't sit around like memorizing equations. That won't do you any good. These are equations. This is more a list of like what you're encouraged or you should feel encouraged or free to use as step 3 GDPs. I just to be super clear from there are equations on this, like the last like 5 equations on the second column are real true, or the last like 6 or 7 everything after the wave equation is true and relevant for this class, but not true and relevant for the exam. Like, don't be confused. Like, you don't, you no, everything at, so like, right. I'm sure you understand what I'm saying. I'm saying, like, everything those are all true, but you don't need those for this exam. Okay. Everything else is, I believe, somehow relevant uh for the exam. Yeah, everything else is somehow, well, maybe this is not. So anyway, okay. So, but you're given them. So don't like sit around memorizing. Oh, then here, notice, how do we, sorry, even know. Okay. Um, Notice here, this is kind of important. It implies that you would be given choices on your exam. So the truth is, yes, by the time your exam is posted, you will get some kind of choices because your actual exam will not be as long as this document is. That's for your sake and for mine, for grading. Okay. But I don't know what choices I'm going to give you over what. Like, and you don't know. And I honestly don't know. So you need to be able to do everything in this exam, in this practice. If you want to rock the actual, you need to be able to do everything in this practice in order to rock the real thing. Then just know when you get to the real thing, it won't be as long. But you follow what I'm saying? Stop me if you don't follow what I'm saying. But you can trust I will give you some kind of choice, but it's not going to be this choice, if that makes sense. Or it isn't necessarily anyway. Okay. All right. So then now I am going to like help you solve some of the problems on here, like today and Wednesday. I will literally walk through some of the solutions, but I'm sort of going to do it maybe even with your input or depending on what questions you ask me. So if nothing else, I would really say we're going to continue walking through the practice on Wednesday. I need you to know again, I'm not doing everything with you. I'm doing some of it with you just to show you that we're both in this together. I'm going to do some of it with you today and Wednesday, but not all of it. So, you should really come prepared Wednesday you should really have started this and tried this and see what you really need help with on Wednesday and tell me what to do. And the more specific, I mean, on any of this document, the more specific questions you have Wednesday, the more of them I can answer in one period. And then be wise too. Like when you go in Thursday, I don't know how Professor Talley is going to handle it, but it'd be in your best interest to be tracking whatever we do this week. And by the time you come in Thursday to lab, be like, oh, the one thing Yavarab hasn't said anything about is problem 4. Can we like deal with that in lab? You know what I'm saying? Like, I mean, don't tell her what to do, but she is you know what I'm saying. So, okay. So for the moment, I'm just giving overview. This problem right here, I don't know if you may look at it and say, wait, electricity, currents, we haven't talked anything about that yet. I know that we have not. Just like when you looked at a certain homework initially, a homework that this is very much based on, this is homework 3. You should be able to recognize that this is essentially homework 3 with just the scenario and the numbers being changed. And when you did homework 3, you didn't know anything about weather either. And we still don't. I don't know anything about weather, right? You just were told, okay, assume that weather follows this certain differential equation that we're studying in class. So now go. And same thing here, right? I hope you can see, you'll know you're sort of on track. If you look at this and you're like, oh, this is homework 3 essentially. Okay, instead of weather, it's like an electrical current. So it's not assuming that I know things about electrical currents. It's the nature of physics. It's assuming if you know fundamentals, you can apply them to new situations. So this is, again, I may go back to it and do it more thoroughly in a second, but just so you know, this is homework 3. And the key thing to know, disguised, and the key thing to know here is that if that is the differential equation, d2i over dt squared equals negative constant times I, right? Then you automatically know that I oscillates cosinusoidally as a function of t, and that right, I almost want to switch screen, but automatically as soon as you see that different, if you've been studying or if you've been paying attention in this class, you know that if that differential equation is true of I, then I equals I naught cosine omega t, and omega must be the square root of that constant in the differential equation. Now, and if you want me to say that again in a minute, I happily will. But in fact, let me back up and say 2 things. Notice this problem is not about waves. This problem is about oscillation. The differential equation that's being given to you has an I in it, a capital I in it. We've never dealt with I before, but it doesn't matter. It could have been a Y, it could have been an X or a theta. It's just some measurable time dependent variable, right? So I is oscillating in time. I must equal I naught cosine omega t. I'm asserting that. But what I'm asserting to you, pro tip, or like if you're still paying attention to me, is that's the first insight you'd want to make in this problem, that I must equal I naught cosine omega t. But you're going to want, I don't mean to point at you, want to explain that to me thoroughly, literally. So okay, let me back up. I mean, I would draw this, but I'm trying not to rabbit hole. I'm trying to give you a big picture here. Like if you got to this problem in the exam, the first thing you would do, just like with homework 3, is you would draw a diagram. What would the diagram be? It would be some kind of cosine graph, right? And I would be on the y-axis and t would be on the horizontal axis. And the y-intercept would be positive 8 amperes. Stop me if I'm talking too abstractly, but again, okay, stop. But anyway, you would have like a cosine graph and it would be labeled current versus time. And the y-intercept would be 8 amperes. So you'd have a picture, labeled axes, and a representative value. That would be your diagram, step one. And then you'd write the other facts underneath. Well, those are the basic facts. Then step two, what is the question? Well, for part one, the question is like solve for F. Like, what is F? The frequency, right? Step three, GDP. Step three would be something like if DI or step three would be something like in general, like we've put on the board many times, if d2z dt squared equals negative omega squared z, then z equals z naught cosine omega t. Like I'm saying z on purpose. Like I'm saying in your step three for this problem, especially, oh, I see there's things in the chat. I will look in the chat in 1 second. But just to finish this thought, especially assuming this is the first problem you're doing in the exam. So like you're introducing the material to me, you're introducing yourself to me at this point in the document. So in step three, you would go to general, like Z variables and say like, all right, what's in general true is if I have a differential equation of this form, then this is the solution. And you would show me that extensively at this stage in the document, like, and this is not just an arbitrary example, like I'm being literal here. You would literally pause before doing anything further, and you would write out like z equals z naught cosine omega t and take two derivatives of it to show me that then d2z dt squared equals negative omega squared z. Like you would literally show me the thing that we, spent weeks leading up to. You would show me why you believe that if you have a differential equation of this form, then a solution of it is a cosine solution for which the angular frequency, like the omega term, the term right before the t, must ultimately be the square root of the constant in the differential equation. Like you would walk me through that by taking two derivatives. Okay, like that's like literally the first thing I usually look for in this. Did they take two derivatives to show me why they know? All right. Can they show me that they understand why the square root of the constant in a differential equation of this form is the angular frequency at which the function cosines, right? I mean, and again, if you understand even what I'm saying, good. If you don't, and I will look in the chat in a moment. I see there's two things there, but I'm being a little bit abstract, but I'm also hoping that at this point in the course, you were kind of communicating like your job. And especially for those of you who had asked me, like, is there an answer key? I'm not going to give you an answer key, but I'm telling you right now, like pro tip, like what I'm looking for as an example, at that stage, step three, you would be laying out the fact that that you got to square root that constant in order to make any headway in this problem. And the reason you do is for reasons like taking derivatives. So you would over explain when in doubt. Over explain, especially if it's the first time you're introducing a concept in the document. Over explain it. Maybe even make an extra picture. Maybe use another color. Maybe like do math over here and then like with arrows put English over there. You know what I'm saying? Like get personal. I don't mean personal, like asking about, but I mean like be yourself, like express yourself. Like, and that's why you get my point. So that's what you would do in step three. I'm going to look in the chat. I swear I am. But then in step four, you would say here, omega squared equals 1.44 pi squared times 10 to the fourth. Therefore, right, the constant. I just read it off the differential equation. Therefore, omega is square root of that, i.e. like 1.2 pi times 10 to the second or whatever the square root of. I just did that wrong, but whatever the square root is, you would write is what omega is. And then you would say F frequency that you're solving for equals omega divided by 2 pi. I mean, literally, I am walking you through this. I'm just saying it vocally because I kind of want to get to like harder problems, to be honest. But like that's what you would do in step four. You would say omega equals the square root of that number. Then F equals omega over 2 pi. you would get the number. And because here it's literally asked, it says in hertz rounded to three significant figures. It's not to be intimidating. I'm not saying this is chemistry but I am saying like that's a hint. Don't leave it in terms of pi is what that's saying. Like actually like get approximate numbers and you'll get a frequency. I'm even going to tell you here, and then I will shut up and look in the chat. But for your first answer, and then you get a frequency and you would circle it and say, if given the above, F equals blah hertz, blah cycles per second. Yeah, that's what it's asking. It's literally asking how frequently does the device cycle through its full range of total magnitudes from its maximum through zero to its minimum all the way back. Like that's a lot of words to confirm. We're talking about how many full cycles does it make per second. And I'm going to tell you right now, you're not expected to know anything about electricity here. But you will discover something about electricity, or you will realize that when you get an answer here, I believe that the at least in this example for the practice exam, the numbers have been designed. So after you go through all this work, I believe the answer you're going to get is F equals 60 hertz. Because in fact, that is what the frequency of alternating current is in it. Like you may have heard of that. Like I'm not saying you, but you may, if you live in America, like you may know that when you plug things into the wall, the electricity is coming out at 60 hertz. Like, so I'm just, so this is not a BS problem. Like it actually means something, but, and the fact that you'll get, even, so you will get sort of a clean number at the end, and that doesn't always happen in physics. But when it happens, when you get that sort of a clean or recognizable number, it's often a good sign that you're like doing something right. Okay, I'm going to pause first, but that would be the answer to that. And that's an example of how to do the 5-step method. I'm going to pause because there's definitely things in the chat. Hold on, sorry. Oh, yeah, no problem about the delay person. You warned me. No problem. Thank you. And then how do you know? Oh, okay. This is a good question. It's funny. This comes up a lot. In other contexts too. So someone's asking in the chat, how do you know if you need to draw a cosine or a sine graph? Okay, so that's a very good question. I mean, well, the real answer is because the main difference between sine and cosine is that the sine of zero is zero. Like sine graphs start at the origin and then go up and that, right? I mean, cosine and sine graphs look very similar. I mean, it's a very good question. But cosine graphs don't start at 0, 0. They start at some value on the y-axis. So whenever we have a situation in physics or math where, like here it says in the problem, it says it says after it gives you the equation, it says imagine further the wall device for which the current at t equals 0 is I naught equals plus 8 amperes. Like the fact that it gives you a value for I, a non-zero value for I, when t equals 0, that's why you should use cosine, if that makes sense. Now, and the person who asked me, it's a really good question. So please let me know in the chat if I answered it. But I'll also say that that's generally what happens in physics. Like generally, when in doubt, in these kind of situations, we tend to like cosine for that reason. Because in physics, if we started, it all goes back to the mass on the spring. If the mass on the spring were initially at equilibrium, it never would go anywhere. So we really wouldn't get any kind of physics situation. When in doubt, I'd go with cosine. Hopefully that makes sense. Okay. I'm gonna go on. Wait, but the person who asked, is that well, okay. So then it asks, oh, okay, there's a chat. Thank you. Wait. Oh yeah. Oh, maybe I misunderstood the question. I'm sorry. Thank you for following up in the chat. Oh, okay. So maybe the question, so the person wrote, But what about the general question of like when I should draw a graph? Yeah, okay, okay. So I took the question to mean like whether it's sine or cosine, but the person's really asking like, wait, but how do I even know? Like, how did I know that I was supposed to even do cosine or sine in the first place? Okay. In other words, how did I know I was supposed to do a graph? Fair point. I see your point. Here's what I'm saying, or here's what I'll say is you always want to start with a diagram, even if I didn't give you one. That is definitely part of this exam. Like that's part of the 5-step method is like, no matter what, and especially when a problem begins, you've got to start with some kind of diagram. I mean, once the problem is rolling and it's the same situation, but a lot of different questions, you can keep saying C above, but you have to start with a diagram. But then my hint is if it's a very mathy question, if pure math has been presented, um, but not, yeah, like the way to know that what the kind of, let me back up, let me back up. Here's really how to know to everybody. It's a good question. I always want a diagram first, and sometimes these problems give you a diagram to sort of mimic, and sometimes they don't. Of course, it's a little bit harder to remember to do a diagram when you weren't given one to mimic, but it's actually all the more necessary to do one when you weren't given one to mimic. The standard of a diagram, the purpose of a diagram is to define the constants and the variables that are going to be used in your step 3 and step 4 in all your computations. Like all the letters that you're going to be using to compute the answer, to solve the problem in step 3 and step 4. Those are the things that we need to define first before using them. And the way we define them is in a picture. So here's really what I'm saying to that question. The things that have to be defined in order to do this problem, like I and T are in effect going to have to be defined, but more specifically, you're going to have to show me there's no way you could solve this problem without dealing with omega. The key of this whole problem is really knowing that omega is the square root of 1.44 pi squared times 10 to the fourth. So if you're going to be using omega throughout this whole problem, what you really need is a picture, a diagram in which omega is a label. And therefore, whatever it's labeling in that picture is now the definition of it for the rest of the problem. So for my money, once you're having to define something like omega, something abstract and mathematical, like radians per second, it's very hard to do that in a regular everyday picture. I mean, it possibly could be done. And if you could, if you made, and I'm actually really glad the person's asking this, I'll tell you why in a second, but like, so I'm not saying that the cosine graph is the only possible diagram. I mean, I think it's the most common and most safe possible diagram. But if you were to be able to somehow draw a picture of electricity or like electrical current somehow coming through a wire or something, and if you were able to draw a picture that literally made I clear and made I naught, the 8 clear and made time clear and somehow made explicit what omega means in that picture, even if it's not a graph, now that I'm thinking on it, yeah, I would fully accept that. I think the graph is the easiest way to depict omega. So that's why I was suggesting a graph. But it's really good. This is not a sidebar. I will go on in a minute, but it's not a sidebar what this person's asking because I don't even know if he or she knows. But now that I think on it, in the past, whenever I've gotten this exam, to grade, it's true that a lot of people on this first question, they don't draw a graph. They just draw like a socket in a wall, and they just like have current coming out of the socket. And I tend to mark that wrong. Like, come on, I need a cosine here or something. Now that and maybe the person knows that the person asking, and maybe those people were shocked. Like, how did I know I had to draw a cosine? I mean, fair point. But here's where I'm going with like, I'll now be more alert now that I literally will be more alert now that the person is asking me this in the chat. Like, if you don't think to draw a graph and you draw like a socket in a wall with current coming out of it or something, okay, that's cool. But your current, somehow you've got to show that your current in some way is going up and down, right? And you've got to somehow show where the omega relates to the up, down, up and down. And here's why God or Descartes invented graphs in the first place is because the truth of the matter is the current. I mean, I'm getting myself a little carried away here, but like this is why we like graphs really at all in science and math is because you could start drawing a picture of a socket in a wall with electricity coming out, and that's cool. Like we can both now know what you're talking about. But the electricity isn't literally going up and then down and then up. Like I hope that what's coming out of my wall isn't literally like pointing toward the ceiling and then pointing toward the floor and then pointing to right. It's not geographically going up and down. What its value is going up and down. So somehow or other, your picture is going to turn into a representation of values. It's not really a picture once you have bumps and valleys. It's a representation of, and that's what a graph is. So somehow your picture is sort of going to turn into a graph if it's actually conveying the information it needs to convey. But I will look out if it's not a standard graph and it works better for you than a standard graph, that is fine as long as every piece of information that I need, specifically omega, is there. So, okay. So honestly, the person who just asked that, if nothing else, just helped me be a more compassionate, flexible grader on this for real. So you can all thank her or him for that. But now, okay, wait. Well, I mean, yeah, well, I think I just did. I mean, look, if a question, the bottom line is if the piece of information given, so I'm following up on a follow-up in the chat and then I'll move on. I mean, it's fair. And you should all be asking, like, if I just answer a question, I will still walk through a problem on Wednesday. I will. And you're going to have a full lab period to do this. So if you all ask me questions all period today about the exam, it's fine. And it's not a waste of your time. It's okay. I mean, I hope you all understand that. Excuse me. So the person just asked, can I give you hints? I can't, I can't, it's totally snowing where I'm teaching from. Is it snowing? It's snowing. I'm so depressed. I'm like, I love snow is beautiful, but I'm so over this already. Oh, sorry. Can I give you hints as to how to know whether it's a graph or not? Yeah, here's my besides like what I just said, here's my biggest, most concrete hint of whether you should be like on the lookout for a graph is that the key piece of information that was given to you in this problem was a differential. I'm not saying this sarcastically, but the key given was a differential equation. That is a very abstract mathematical piece of information. Like it's really not a physical piece of information. It's very mathematical. That's a hint that the kind of picture that you need to draw is a mathematical picture, if that makes sense. And again, to everybody, even if you're not the one asking, even if you're like, I already knew to draw a graph, can you go on, Yaverbaum? Like the broader takeaway of this discussion is that when you look at that problem, don't be thinking about what you know or don't know about wires or electricity. It's not about that. Just like on homework 3, don't get bogged down in picturing weather. The whole thing about physics and math is we're investigating the underlying principle that makes all these things similar. So the question is really about the math that's underlying currents in time. So it's a very mathy question. So that's the hint that I think you want to be thinking about graphs. But okay, cool. Okay. And plus, I'm going to keep walking through this. So if I see another one as I walk through, I'll tell you. Okay. But good question, good dialogue, good talk. All right. Now, the rest of these questions here are, I'm not, if I'm, are yours to do. They're not tricks. Like if you think they're straightforward, maybe they are, but you should still provide steps. And if you think it's all the same diagram, just say see above for diagram, stuff like that. But it's very mathy, the whole thing. It's really all about, do you understand how the cosine solution relates to the differential equation? And one other hint, well, until you get to 6 on this, Oh, is there no five? Sorry, I guess there's no five. Yeah, there used to be a five. Sorry, I'll fix that. There's no five. It's not you, it's me. But once you get to the last, until you get to the last, like all of this is about simple harmonic oscillation, like as we first studied it. So the key to this whole thing is like I equals I naught cosine omega t plus zero. Like there's no phase constant that's relevant or necessary for any of what you're doing in this whole sheet until you get to six. Then there is a phase constant. Um, and I'll tell you this now relates full circle back to the original question or how I misunderstood the original question. Um, like it's asking in number six, is blah, 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 sine, blah, 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 a solution to the differential equation? Like, don't think automatically that sine can't be a solution. Cosine is what we've been emphasizing. But if you then followed the discussion, if you followed how we then eventually realized that there could be a phase constant, right, in the argument, then once there's a phase constant, that means it could be sine or cosine. And I want you to understand that. Like sine, and that's why this original, so sine, if you differentiate sine twice, you get negative sine, right? So sine in general also works. It's just like e to the I omega that works. So don't say that answer six is false just automatically, just because there's a sine in there, not a cosine. What you have to do is take two derivatives and see if the example that was given to you produces the original differential equation and condition or not. It's just like homework too. Okay, okay. So you could talk about that more, or you could ask me more about that on Wednesday, or you could talk about it. Okay, same thing with now. Okay, here's a perfect. So the person who's at question two is also very mathy. Is it possible that like when I give you choices on your exam that I may do it so that you have a choice between doing one or two and not both? Maybe like maybe I don't need you to do all of one and all of two. They're both very mathy. They're both very much on the same topic of the math of this differential equation. So yes, to the person who was asking me in chat about cosines and stuff, even on this too, even if the very first question is just show why blah is or is not a solution, do the five-step method and start with a graph, a cosine, or in this case, a sine graph. Like, because it's giving you that. Like, yes, I would right here also start with a graph because it's so mathy. Hopefully that's helpful to the person who was asking before. And so here, yes, it's just like more of the same. The whole issue is to take two derivatives and see if what you get relates to the above given equation. You can now, if you've already done problem one, you can start saying things like see problem one, part B for further explanation. You can do that, but make sure that it's there be very specific. Guide me to where I need to look for any explanations that you don't want to repeat here. Also, don't be thrown like this is doing it on purpose. Like that differential equation that's given at the top, that is, if you're getting used to this, you will recognize that that equation, that is simple harmonic oscillation. Even though what's in the, sorry. Wait, let me, hold on. It is not simple harmonic oscillation, that topic. It's an equation. Um, and things could fit it or not. And you find out by taking two derivatives when it eventually asks you, or it actually never asks you, but notice that for what it's worth, there's a plus sign there, not a minus. That doesn't mean you still can't do the math of all this. It just means it's not simple harmonic oscillation if it were to ask you. Like right here in the practice test, it doesn't actually ask you that, but that'd be a perfectly one thing I easily could do on Friday is just throw that in. Like, is this a simple harmonic oscillator or not? And it's not. Anything that solves that, certain things could solve it. Like maybe the sign expression does, I don't know. But even if it does, it's still not simple harmonic motion because that thing has a plus sign rather than a minus. Um, is it okay that the constant has a cube in it? Yes, it is okay. Like that might throw you off at first that there's a cube sitting in there, but that's just a constant being cubed. A constant cubed is still a constant. So part of that's what we're trying to get you used to here. Like don't let that kind of stuff throw you off. But okay, Same thing. So we're still dealing with that differential equation. Even when we get down to 2, it gives you an example, y equals negative k e to the blah, 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 t. Is it possible that that thing works? It's totally possible. You're going to have to try. Like it's an e to the I something t, and then it has a phase constant in it. It is totally possible that that works. Like it has the right form. So you're going to have to uh, check to see. Now, I guess I'll give you a pro tip. I mean, I'll tell you right now. It's totally possible. Like it has the right form for a simple harmonic oscillator because it's like a constant times e to the I, blah, blah, blah. But that would make it work for a simple harmonic oscillator. I I think it's not going to. What I'm trying to say is because that original equation has a plus sign in it, I don't think that this y-e thing is going to work. You'll find out. But and of course, this is an example. Will you have a problem like this on Friday? Sure. But will I change around the equations and put plus signs in different places? I will. So, don't get bogged down. Just know how to take two derivatives and check. Um, okay. All right. If you have any questions, I can answer them, but I'm going to go say, it's very repetitive, this problem. It's not very glamorous. It's basically homework too, but it's just really trying to drum in um, some things are simple harmonic oscillators and some things are not. Um, okay. Now then we get to problem 2. Hold on. Problem 3. This is what we have 18 minutes left. I can tell you right now, if we get cut off, I guarantee you that there are full walkthroughs of this problem. There are videos in past semesters. I mean, you may have to look around a little bit. Maybe one of them is labeled problem 3, but they're certainly at least labeled midterm walkthrough. Definitely, I walk through this problem in past videos. I still probably will try with you, but if I get cut off or something, I know you can find them. Um, the key of this problem, this sort of goes back to lab number 2. The overall summary of this problem is that here we're backing up and trying to show that we have enough physics to see why there are systems in the world that aren't masses on springs, but nonetheless behave exactly like masses on springs. One example is the simple small angle planar pendulum. A planar, and this is really what was going on in lab 2. Like the planar pendulum, the small angle planar pendulum goes back and forth, not sort of like a mass on a spring goes back and forth, but precisely the way a mass on a spring goes back and forth. Like the math is identical. Both systems can be described by the same second order differential equation. The difference is that a mass going back and forth on a spring, the dependent variable is x, whereas a pendulum going back and forth on a string, the dependent variable is theta. But you can show that theta obeys a differential equation, and therefore, like you could show that theta equals theta naught cosine omega t for a pendulum, just like x equals x naught cosine omega t for a mass on a spring, or just like in the original problem, I equals I naught cosine omega t for a current. Okay, but here this is a more physical problem. We're asking you to physically show us why we believe that a pendulum can be described by that math. So a big hint for this problem, or a big pro tip, whatever. What do I want to? Well, I hope it's clear that when it says whenever the particle arrives at a location of theta equals pi over 12 radians, like that, it says that's a turning point. That's the amplitude of the pendulum. So in other words, theta naught equals pi over 12 radians, or in other words, like 3 degree. Oh my God, I'm losing my mind. 15 degrees. Am I losing my mind? Yeah, 15 degrees, right? Which is reasonable that's a reasonable number for, um, I mean, if the angle gets too big, then the thing breaks down. But if you start a pendulum at like 15 degrees, pi over 12 radians, it will oscillate harmonically, as you saw in lab two. Wait, so the hint I was about to give you, there is a hint for this, or something to watch out for. The thing to watch out for is that you, yeah, is that you should never assume anything about lowercase g. When you do everything in this problem until you get to part six, until you get to the end of this problem, you're the number 9.8 should not figure into anything you're doing. You have all the information you need to solve everything, kind of like in part one of this exam. Um, you, as long as you know that it's an oscillator and that it's obeying that oscillation equation, you could figure out everything you need. In other words, I mean, the hint I'm trying to say is that just like in problem one, the omega for this oscillator has to be the square root of the constant in that differential equation. Again, it's the same thing. Like omega squared is pi squared over 64. If I'm just looking at the equation right in the center of your page right now. So omega equals pi over 8 radians per second. The logic of that, you can literally say, see part A of problem one, where I explained why that has to be true, assuming you did. If there's choices in this exam, and this is the first time you're doing that, then you've got to explain it by taking two derivatives, by backing up and saying, if we have a differential equation, d2z dt squared equals negative omega squared z, then the solution is a cosine where, look, I'll show you, I'll take two derivatives and I'll show you how when I do the chain rule, the omega gets squared, okay, and stop me if you don't know what I'm saying. Or, or if you think you will never know what I'm saying unless I explain, whatever. So somewhere in the exam, you're thoroughly explaining that. Like I've never heard it before. Like you're showing me that you get it. But once you get it, that the square root of that constant is omega. So omega for this problem is pi over 8 radians per second, right? So then when you go to do part two here in the middle, Roman numeral lowercase 2, approximating the number of hertz, um, you're really solving the same type of thing you did 5 minutes ago on the other, I mean, on, you're doing the same thing you did for that current problem, problem one. But then notice, oh God, yeah, this is a weird question. There's kind of an error in this question. Okay, I'm glad we're walking through this together. It says, I will change this in your actual exam, or is it possible? I'm just trying to think if I can actually correct this error right now in the doc. Well, this kind of an error in the doc. It says what is the standard frequency, but then it asks how many seconds. Well, it's asking two questions. I guess if I didn't change the document to make it more clear, what you have to do is take the document seriously. It's in one question, it's asking two questions. Honestly, it's first asking standard frequency. That means cycles per second. That means omega over 2 pi. That would mean in this case, pi over 8 divided by 2 pi, like literally, right? So, you have to do the fraction and the pi's will cancel, but and then convert that, like don't leave it as pi. It says three significant digits. So you get standard frequency measured in hertz. Um, but then it says approximate the three significant digits necessary. How many seconds should we expect this pendulum to take the first time it gets from the equilibrium point all the way back to its original starting position? Now that's like now you have to understand, like, what is it really asking there? What it's really asking is, what is 3/4 of capital T? It's asking what is 3/4 of a period, right? Like it's saying, and so it's a different question. It really should be two different questions. I apologize, but it's asking both of them. So as it's written, you got to answer both. It's not meant to be a trick. It just happened. Um, But read it. It says from the first time it gets from the equilibrium point all the way back to the original. So from equilibrium to negative amplitude, back to equilibrium, back to original amplitude. That's 3/4 of the way. I hope you of a cycle. Please stop me if you don't understand. But what it's asking there is what is 3/4 of capital T? What's capital T? Period. How do you get period? You flip the frequency. How do you get the frequency? Omega over 2 pi. Right? These are review. Stop me if I'm not making sense, but that's what I think you need to do to solve that problem. So, so you don't need anything about lowercase g or anything like that to do these things. Then it's 3. It says, okay, and I'm watching the clock. Again, I hope this is, can I just wait? I'm sorry. It makes me a little nervous that I'm just like yelling at the top of my lungs and I'm not writing anything down. Can I honestly, but the reason I'm not writing anything down is if I start writing, then I'm not going to cover as much. So can I just ask you, well, we have 9 minutes left. Just raise your electronic hand if this is helping you at all with the exam that I'm doing this walkthrough like this. That was pretty fast. Okay. That was pretty fast. Okay, cool. Fine. Good. I'm glad. I mean, I'm not trying to put you on. I mean, it wasn't a lot of hands, but okay. All right. Thank you. I'm going to keep going then. And I'm again, Wednesday, I'll literally like write out at least a solution, but it's sort of this is way like this. You know what I'm saying? This is like the 50,000 feet view. And then I'll zoom in Wednesday. But I just can't write out the whole thing because okay. Anyway, so I'm going to keep going like this. So 3, when it says, what's the maximum speed ever achieved by this particle? That is not an easy question. I mean, it's asking what's the speed at the bottom of the pendulum swing, right? This goes back to your lab. This also goes back to homework 1. Like, would you need, well, oh yeah, first thing you need to know, and you need to explain to me, if you're going to solve for that maximum speed, you need to explain the maximum speed occurs at equilibrium. What? Oh, sorry. Is that a question? Yes, Lear, go. Sorry. Yeah. Or were you just raising it from before? Or do you have a
No,
question?
sorry,
Lear,
I'm
if you have a
sorry, it
question.
was a mistake. It was a mistake. Sorry, I'm trying to lower the hand. I'm sorry.
Oh, no problem. Okay. Also, it's weird that I can lower it for you. That no problem. But you know, it's really weird that I just heard Lear say that because technically he's on mute. I don't even know how I just heard it. But okay. But cool, no problem. Okay. Um, maximum speed occurs at equilibrium. You want to justify that before you go, like that would be again a step 3 or something. Like what is that? Conservation of energy. The maximum kinetic energy will occur at minimum potential energy, right? So like take your time to explain it. It comes from homework what like what we knew it was true on a mass on a spring, but we're now the whole idea is we're applying all that knowledge to any kind of oscillator. And also, pro tip, so you're going to explain that what you're solving for is the speed at equilibrium. In other words, the bottom of this pendulum spring. I'll tell you this swing, and I'll tell you how to do that in a second. But also, pro tip or advice for this exam. I'm really trying to emphasize, especially for those of you who have not taken an exam with me before. What we want is an authentic document of process. We want you to explain, to demonstrate like your actual fluent understanding of these concepts. We want you to show how you're really learning to think and speak in the language of physics. Now that means learning. Like it's understood that you're a student in a class. I'm not expecting you to have a Nobel Prize. And it's also understood that I'm just some dude. I'm just some professor in a class. Like I'm not getting a Nobel Prize for this. Right? Like neither of us is Einstein. It's not about do we know all the physics in the world? It's about are we increasingly able to express and break down the physics that we do know, right? Where I'm going with this is like all this how to not cheat speech. What I'm saying, but also like how to get an A, like no matter who you are. I'm saying that since the exam is a presentation of process, not just a recitation of answers, it's a presentation of process. What that means is anytime you think you understand something, even if, or especially if you think it's very obvious, very simple to you, that's all the more reason you should over-explain it, not under-explain it. People make the mistake in physics, often things seem really confusing and out of reach. Then we understand them, and then the minute we understand them, we're like, oh, that's totally obvious. I was just an idiot for not understanding it before, or the professor was just an ass for not making it clear before. Like literally, we're always like either angry at ourselves or angry at the professor in physics once we get something, because we're like, how did I not know that before? Right? That's the nature of physics. That is not you or me. That's what somehow, but the important thing is like, no, it's not just because it makes sense doesn't mean it was obvious. It wasn't obvious. It just makes sense once you think about it enough. So what you want to do is the parts that now make sense to you in the exam, don't think that because they make sense to you that they're self-evident. Break them down into steps. One of the reasons for, and I know I'm dragging this out, but this is like a really important tip for the exam. One of the reasons for looking back at the old homeworks, even the ones that you didn't get feedback on, proper feedback on, or even the ones that you're still going to get more points on after this exam, because I'm not taking down the portals, even ones that are incomplete or whatever. The reason to look back at old homeworks is to remind yourself of what it felt like when it didn't make any sense at all. Like on this right? Like literally, you look back and you're like, oh my God, I remember when this was all gibberish. It didn't mean anything to me. Now I get it, right? Okay, so if you didn't get it before, but now you get something, that means it is somehow a process. It's not a thing that's just been sitting in your brain as obvious the whole time. So what you want to do is break it down into the step sizes that got accumulated in the last month. Like remind yourself of what wasn't clear before, and that's the part that you're now going to make clear to me. Like you're teaching me the unfolding of the physics. The reason I'm making a big deal of that, saying over explain stuff even when you think it makes obvious sense, because that also protects you. Because the more you do that in the beginning of the document, the more you over explain things that you do understand, the more as you proceed through the document, if you get to something that you still authentically don't understand, like you even know what the steps are, your friends showed you, you see them on the internet, like even if you know what the steps are, but in your heart, they still don't really work for you the way other things do, you literally in the exam can say and should say things like, now we divide both sides by 2. I don't really know why, actually, or I'm not really comfortable with this, but I believe that the proper thing now is to divide both sides by 2, or like whatever, or by 2 pi, right? And if you literally authentically write out, this is the step, but actually it still doesn't make sense, or even better, but it doesn't make sense to me. It seems to contradict this other thing, but I believe this is what we do. The more you honestly walk me through the things that you don't feel comfortable with, I promise you, you're getting points for that. You want an authentic dialogue between you and me of what you do and don't understand. And of course, the more you show that when you do understand, you know what to do, the more it's actually going to be very engaging and sympathetic when you say, actually, this part I like literally don't understand. And if you do that in your draft documents, like on the practice or like tomorrow or Thursday with Mercedes, I am telling you that the more you literally write out, I think we divide both sides by 2 pi, but I actually don't get why. The moment you write that down, 75% chance it's going to occur to you right in that moment why, but it never would have if you didn't write down, I don't understand why. Literally. So be as authentic as possible, even about the stuff, over explain the stuff you do understand, and over reveal and confess the stuff. Sorry, over explain the stuff you do understand and over confess the stuff that you don't. You will see that that will make together a much more successful and authentic and trustworthy and A-level document than anything else you could do. Okay, I'm going to go. I know we have 1 minute. So for 3, I mean, I'll pick up on this on Wednesday, or if you have any other questions. But what's the maximum speed ever achieved by this particle? The way to solve for it is to do conservation of energy. Well, I'll continue with that on Wednesday. But you got to do mgh plus 1 half mv squared here equals mgh plus 1 half mv squared there. But then figure out the h's and the v's is a little tricky. So I'll pick up, remind me on Wednesday. And maybe I'll do something totally different in the other section in the afternoon so I can get, anyway, whatever. I'll see you Wednesday. But come with questions Wednesday. Thank you. Thank you.
Bye, Professor.
Bye. Bye. Yes, have a good day. Thank you.
Professor, can I have a question, please?
Yes, wait, I'm going to stop the recording.